Okay, so this short little clip is to fill in a little section of today's lecture that didn't get recorded. So we had taken a break. When we came back, we decided to work with this and try to simplify it. So the first thing I notice when I look at this numerator is that we have a VI in front and a VI in the middle, and everything's multiplied together. So we can just simplify by writing it as VI squared. And what's left is a 2 times a sine of theta times a cosine of theta. And I reorganized them, reordered them in this way because there's a trig identity that says 2 sine of theta cosine of theta equals the sine of 2 times theta. So you don't even know that identity, but it's useful to use it right now because it can give us a simpler form for this equation. That form is delta x equals v initial squared over g times the sine of 2 theta. So I'm basically taking all of this stuff outside of the fraction and replacing it with sine of 2 theta. Now this equation is useful enough that it gets its own name, and often this delta x is replaced with an r. So it's called the range equation. So we can say in this problem the range equals v initial squared over g times the sine of 2 theta. This is a very handy equation to use as long as we remember its limitation. Its limitation is that delta y has to be 0. So if we try to use it in a case kicking something off of a cliff that lands on the ground below us, and we try to use this, it will be totally wrong. Okay, but situations where delta y equals 0 happen so frequently that it's worth it to have this equation just hanging around. So in our current problem, let's see, what was our velocity? We had 40 meters per second. So 40 squared over 9.8 times the sine. This is not 20, it's 2 times theta. So that's 2 times 20. Let me make that a little more clear that these are thetas. And so we're doubling the angle, sine of 40 degrees times 40 squared divided by 9.8 is 104.9 meters. So Robert Lewandowski is a beast, I think is what I said the first time, if he can go all this far. So that's kind of what was missing. And then we went back and looked at this main equation and started doing some conceptual work, which is captured on the next video. So sorry about that. It's not exactly what happened in class, but it's as close as I can approximate. Thanks.